All right. So let's start. Hi, Dhanushi.
Sir.
So we have almost everybody. We have few kids missing. He will be joining in a little bit. Here is here. We are waiting for. We are missing Shravya right now. Sara and Neil, and then who else? Ananya. So yeah, we'll actually get started, and then we'll see who joins when. But before we get started, a quick announcement for you guys that I will take a break during the Thanksgiving and during Christmas. Hey Pranit. So during Thanksgiving, which is I'll probably be away for one day. We'll skip one class during Thanksgiving, and during Christmas, I'll be out for a week. So basically, I'll be away from 22nd till 1st. So we'll have a class on 21st, and then we will have our next class on 4th. So basically we'll be missing 3 classes. But what I'm thinking is, probably if you guys are going to be in town, I will probably try doing one class at least in between, so that there's not too much of a gap. But in case you all have plans or mega plans for Thanksgiving, for Christmas, we'll have to see how we can make sure that there's not much of a discontinuity during this time. Okay, so we'll see how it comes. But yeah, just giving you a heads up that I'll be traveling during Christmas, and then during Thanksgiving I'll be away for one day. I mean, instead of 2 days, we'll probably have class on one day. Okay, if you guys are all around. All right, so let's get started. Hey Neil, hey Sarah. So we seem to have pretty much a full house, except we are missing Shravya right now, and I heard that Ishwari will not be joining today. All right, are we good to get started? So before I start, a quick question to you all. Yaritika.
It wasn't me, sir.
Okay, somebody raised hand, and that hand disappeared. So I'm hoping that was just by chance. Here's Sarah as well. Okay, so quick question to you all. We have tried learning permutation, combination, probability quite a lot. I'm pretty sure many of you would have gotten tired by now, but still a dumb question. Is anybody in the class not clear about what we have learned or tried learning so far? Anything. I mean, it could be as simple, as basic as possible, but it's fine. I mean, that's my job. I mean, if anybody in the class has any doubt about what we have learned so far, please raise your hand and ask for it without any, for lack of a better word, without any shame. It's okay. I mean, it's not that everything we learn it right. There's always an opportunity for learning things in a better way. So anybody having any doubt, let me know. Can I take that as a no? No doubt so far? Okay, I'll take that as a no. But that doesn't mean if you're not saying now, in future, if you have any doubt, you cannot ask it. You can always ask it. And even if we are learning this now, it doesn't mean we'll not come back to this topic again. We'll probably come back to this topic maybe a few months down the line. Okay, because the idea is whatever we have to learn for SAT or for your school, college preparation, we will learn all the concepts couple of times, so that it becomes like something very close to us conceptually. All right, so let's quickly look at what are the things that we wanted to learn today. So if you guys got a chance to look at what I posted in WhatsApp, the thing that we wanted to cover today were compound probability of independent events, understanding what is dependent event and what is dependent probability and what is independent probability, and then look at some addition rule for probability and refer it with the refer it to the Venn diagram. Does that sound like a okay plan, or you guys have anything that you want to raise before I start? Shall I move on? Okay. All right. So let's, and I promise this is the last class on probability combination and permutation, at least for this iteration. Okay. We'll probably come back to this in future months, not now. So what do we mean by compound probability? That's a question to you all. What would be your interpretation of compound probability? Or what would be your understanding of dependent event versus independent event? Any example that you guys can throw? Somebody has to speak up, otherwise I will call out the names.
Is it two joint probabilities?
Compound probabilities, two joint probabilities. Okay, two or more maybe. Okay, that is one English definition. Anybody else? What do you mean by dependent probability or independent probability? Yes, Ritika.
So dependent probability might be a probability that is dependent on an outcome of another probability.
Okay. And what would be independent probability?
Independent it does not depend on any other factors or any other probability other than like the actual problem.
Okay. So you have given the definition. I would want everybody else in the class except Srivatsav and Ritika to give me some example of dependent probability. I mean, again, it could be based on your understanding. I'm not expecting you to be right in the first attempt, but any guess, any idea that you would want to throw or put across.
Would it just be something that like changes based on the other value, like on the independent value?
Okay, and how can you give me some simple example that I can digest? I mean, assume that your teacher is not very intelligent.
Like the XY graph.
Okay, you are assuming your teacher to be intelligent, which is not the case. Now you assume that you're talking to somebody who's claiming to be a teacher who's a 5th grader. How can you explain that to me? I mean, it could be anybody, Dhanushree or anybody. Anjika, give it a try. I mean, Heer, Pranit, yeah.
The probability of rain on the same day, and that could change the probability of flooding on that same day.
Okay, yeah, that's one example. Okay, Chris, yep.
I mean, for compound probability, like for the examples we looked at, like the lottery example and the 4/8 example, like if we were to calculate like the possibility of both of those events occurring together, that would be like an example of compound probability.
Okay, and how do you make me understand what is a dependent probability or independent probability with an example? I mean, I think definition I have gotten, but no. Okay, Vaibhav, you have to say it loud. I don't believe in seeing the text messages. Okay, Dave, go ahead.
I think a compound probability example could be like on Monday there's like a 30% chance to rain, and then like on the rest of the days there could be like a 25% chance, and we combine that together to get like so a total probability.
Okay.
I'm not sure though.
No. See, you guys seem to be having a decent understanding of things. So let me give you a very basic example. No, I understand, Vaibhav. It's okay. That's fine. Yeah, Ritika, go ahead.
So a scenario for like a dependent and independent probability would be like, let's say they make you do a toss before you enter the lottery, and if you get heads, you enter into the lottery, meaning that the lottery probability is dependent on you getting heads. So that probability would be dependent on the first probability, and then the first probability of you getting heads or tails is an independent probability.
Okay, makes sense. Yep. Now, I think you guys are certainly having a good jump start, and I don't see there being a conceptual difference. But let me make it even more explicit by giving you very simple examples. Okay, let's say if I am tossing the coin 3 times. I'm tossing it 3 times. By first toss, I can get a head or I can get a tail. Second toss also I can get a head or I can get a tail. Third toss also I can get a head or I can get a tail. And again, I'm assuming that these are fair coins. When I say fair coins, what it means is the likelihood of getting head and tail are both equal. Let's say if you have a distorted coin which by default falls on the head side, then that is not a fair coin. But in case of a fair coin, when I'm tossing the coin, I can get a head or a tail, and both the events are equally likely. So now my first coin, whether I'm getting a head or a tail, is independent of my second toss. If anybody says that okay, I have tossed the coin 2 times and both the times have got head, that means third time it's more likely that I'll get a tail. No, these are independent. Every toss of a coin has no bearing with what has happened in the past or what might happen in the future. That is why these are called independent probabilities. The probability of head in every toss is independent of what happens in the surrounding. Okay, so that's why it is called dependent probability. Now let's look at second example. I have it doesn't look like a bag. Let's say this is my bag, okay? And inside this I have 3 black marbles and 2 blue marbles, okay? If I'm picking one marble from this one, what is the probability of getting a black in the first pick? Obviously it's 3 out of 5. Yeah. What is the probability of picking a black in the second pick? It becomes 2 out of 4. Because what is the probability of getting what is the probability of getting a first black in the first pick is 3 out of 5. And what is the probability of getting a second black in the second pick is 2 out of 4. And this 2 out of 4 is actually dependent on this pick. Whether it is a black that is getting picked here or a blue that is getting picked here, the first one decides what is the probability that you have for getting a certain pick second time. So that is where this probability is dependent on this one. And you cannot disassociate them. You cannot say that regardless of what gets picked in the first go, my probability of the second pick for a certain color would be independent of the first event. No. Here these two are dependent. Likewise, if I have to, let's say, fill 3 chairs with 5 people, what will be the probability of a particular person getting picked up for the second chair depends on who got picked up in the first place. And the third pick for the third chair is dependent on what has gotten picked in the first and second place. So that is why the probability of this event is dependent on the other 2 probabilities. Yeah. So this is a classic example of dependent and independent probability. Does that make sense to everybody? In simpler way. Yeah? All right. Neil, Sarah, Anjika, Dave, Chris, everybody? Heer?
Yes.
Srivatsa?
Yeah.
Yeah, okay. So again, whenever I call names, this is just to make sure that everybody is with me, okay? Nobody is left alone in this class. Yes, Chris?
Oh, sorry, I did that by mistake.
not a problem. Okay, let me see. Arya and Aryan, you guys are with me so far?
Yes, sir.
Okay. Now, generally, Arya also participates quite a lot. Today, she's been quiet, so that's why I was just checking. All right. And I love when you guys participate, okay? I certainly get that confidence that, okay, when I'm teaching something, all the kids are with me. Anush, it's okay for you so far?
Yes, sir.
Okay. All right. So now let's see again, knowing what is dependent probability versus what is independent probability is, okay, that is a conceptual thing. Now, how do we apply and where do we apply that? So, before I go there, so compound probability when you talk about, right? I was asking you guys to explain what is compound probability. So, compound probability is again, what is a compound? It's a mixture of two things. Two or more things. That is when we call it compound, right? So compound probability is something where you're looking at probability of an event, taking 2-3 events into consideration, right? Like if I say, what is the probability of, let's say if you're tossing, throwing 2 dice, okay? You're throwing 2 dice, okay? So dice have 1 to 6 on this one. I say, what is the probability of getting a sum of numbers as 7 in the 2 throws? Here you will say, okay, what are the different ways I can get it? You'll say, okay, fine, I can get 1, I can get 2, 3, 4, 5 and 6, and here I can get 1, 2, 3, 4, 5 and 6. So what is the situation when I can get a 7 or more? I can get 1 plus 6. Here I get 1 here and 6 here. I can get 6 here and 1 here. That's only where I can get 7 or more. So there are 2 events only, where first one gets you as 1. No, my bad. No, I'm misguiding you. You can get a 1 and a 6, that makes it 7. You can get 2 and a 5, that gets you 7. You can get 2 and a 6, that gets you 7 or more. If I say 7 only, okay, let's say, what is the probability of getting a 7, sum of 7 with the 2 throws? I can get a 1 and 6 to make it 7. I can get 3 and 4 to make a 7. And I can get 4 and 3, that is a 7. I can get a 5 or 2, that gets me a 7. I can get 6 and a 1, that gets me 7. So these are total 6 events, which is getting me 7 when I'm throwing 2 dice. So here, the probability of getting a 7 in the 2 events. Conditional probability and dependent probability, yeah, pretty much. So when you talk about dependent probability, first probability's occurrence decides what will happen in the second probability or second event. So this is where the second one outcome is a condition based on the first event's occurrence, right? So that's why conditional probability and dependent probability, you can use them interchangeably. So here what I was saying was, what is the probability of getting a 7 in 2 throws of dice? So these are the ways I can get 7, and a total number of events we have is 6 times 6, 36 events. So it is 3 plus 3, 6 out of 36. So total probability of getting a 7 is 1 out of 6. And this is nothing but a compound probability. You're talking about this as one event and this is second event, and you are adding the events together. Likewise, you must have dealt with scenarios where we talked about, I'm throwing the coin 3 times. And what is the possibility of getting 2 heads? So here there are 3 events happening together, and we are deriving the probability taking all the 3 events into account. That is where it is called compound probability. Yeah? So compound probability, dependent probability, independent probability, we just understood conceptually. Now let's look at some of the mathematical thumb rules that we need to be aware of while solving the problems. Now, let's take a very simple example. that will resonate very well with you guys. That you go for an exam. Let's say you had a test today, or let's say you have a test tomorrow on a particular subject, and you have not studied, and you have decided not to study for that test. I mean, don't do that. It's not something that I'm recommending. I'm just telling you a scenario. Okay, that you have an exam tomorrow, where you'll be given a test tomorrow, which will be having 5 multiple choice questions. Okay. So, and every question has 4 options: A, B, C, and D. Okay. Now, again, I'm repeating the question. So, you have a test tomorrow which will have 5 questions or 5 MCQs being asked, and every question has 4 options, and you have not studied for it. What is the possibility of, or what is the probability of getting a 50%? Okay, or what percentage of score you could get without preparing for the exam? Okay, I'm not giving you guys a mathematical formula to prepare. I mean, go for exam without preparing for it. But let's look at it. Here, you have 5 questions. Let's say this is question 1, 2, 3, 4, 5. And since you have not studied, this is completely out of context. You go blindfolded for this exam. That means you will just randomly pick one option. You have to tick one of the options, and you just pick one. You don't know which one is correct. So 1 out of 4 is correct here. What is the probability of you getting the right answer for the first question? 1 out of 4. Yep, 25%. Same thing for the second one. 1 out of 4. 1 out of 4. 1 out of 4. 1 out of 4. And again, every question is independent. In every attempt that you make, being blindfolded, it's like the pin the donkey event. Okay, you're just blindly picking up one of the options and hoping, praying that you'll get it right, because you have not studied for it. What is the total probability of you getting these questions right? So here, if you see this event, this event, this event, this event, this event, all these 5 questions are independent of each other. Whether you are getting this right or not doesn't have any bearing with what will happen with remaining 4 questions. So here in this case, when you talk about disconnected events, you're talking about disconnected probability. What will be a total probability here? You will end up multiplying them. When you're talking about independent events, you end up multiplying them all. And that will be your overall probability, which becomes 1 out of 16, 64, 256, 256, 1028. And 1024. Yeah. So 1 out of 1024. This is a probability of getting it right. Or if you want to calculate that in percentage, you will multiply that by 100, and this will give you the overall percentage of you getting the questions right. Your probability of getting it all right is 1 out of 1024, and you can calculate how much it will be. Okay. So what I'm trying to say here is, these are all disconnected events. So when you have multiple disconnected events and you have to find out the overall compound probability of the exam, which is a compound probability of all these events together, you end up just multiplying them. That's the way you relate independent event and use that as a calculation. Now let's look at another example, and then we'll see how the disconnected event and the compound probability plays a role. Let's go back to the same example of tossing 3 coins. you can get a head or tail. So we are talking about tossing 3 coins. What is the probability of getting 2 heads? Okay. Total number of events we are talking about. Here you have 2 events. Here you have 2 events. Here you have 2 events. Okay. Now, what is the probability of getting a head here? It's 1 by 2. What is the probability here of getting head here? 1 by 2. 1 by 2. So if you have to find out what is the probability of getting 2 heads. 2 heads. So you have to look at what is the total probability here. Total number of options are how many? 8, 2 times 4, 8. And what is the probability of getting 2 heads? So head, tail, head, this is one option. Head, tail is another option. Tail, head is another option. Tail is another option. Head is another option. Tail, head is another option. Tail is another option. So with head, you have got head is another option.
No, it's head, tail, tail. You already have head.
Oh, head. Okay. Head,
Tail.
tail. Yeah. So the two options out of this, getting 2 heads. What are those options? This one, and this one. This is 3 out of 8. So here again, you have to look at, first of all, if you're talking about these independent events, then you will just, the total number of options that you have, you'll have to kind of look at how do you treat them independently and then figure out what is the combinations that you're looking at. So, okay, let me not confuse you guys further. Whenever you have a situation like this, the biggest thing that will come to your rescue would be this, the decision tree. Before you try solving any problem, okay, always try framing a decision tree, which will guide you that how you're going to navigate through this particular problem. So when I talked about 3 coins, so you are talking about 3 decision points, and then this one, these are 3 decision points, and every decision point gives you tail or head, and then you find out, kind of navigate through what are different combinations you're talking about, and then apply whether it's falling in the category of permutation or combination or a mix of those. Okay. So let me quickly stop here before I get you guys literally worried. So are you guys with me so far, or it's kind of getting more confusing? Arya, Aryan, here.
Good, sir.
So
I
far.
understand it, sir.
Okay. Ritika, anything that is getting confusing?
Yeah, sir.
Okay. So all that we are doing today is just a consolidation of all that we have done so far. Okay. So we have talked about permutation, what we have talked about combination. We know the basic difference between permutation and combination. When the order matters, that is when you talk about permutation and you apply the permutation formula to find out how many supplies versus how many positions you have to fill, NPR or NPK, whatever you call it. And then if the order doesn't matter, that is when you look at combination as an option, where you just select a group of that many things, and then you try finding out how many groups you can form without bothering about who fits in what place in the group. Okay. And then we are talking about what is the dependent probability, what is independent probability, and how would you kind of deal with those. So we talked about this one, and let's look at, and we just looked at the independent probability and the MCQ one. Let's look at, okay. let's look at something called addition rule for probability. Okay. So let's look at one another example. What is the addition rule? Before we go into mathematical side of it, let's look at a situation or a question where, let's say, you have three yellow fruits, okay, or let me not say fruits because they have different texture, different thing, you can figure it out. Let's say 3 yellow candies, 5 green candies, and 8 blue candies. Okay. Now, if you have all these in a box and you are randomly picking up, picking them up in a pick of 5, candies, what is the possibility of getting more than 3 blues? Through 3 blue candies. 3 blue plus, okay, 3 blue plus yellow. Meaning, I'm saying that I have 3 yellow, 5 green and 8 blue candies. I'm randomly picking 5 candies out of it. What is the possibility of sum of the candies is greater than 3 by counting only the blue and yellow ones? Let me repeat the question. So I have 3 yellow, 5 green and 8 blue candies in a box, and we are blindfolded. We are picking up 5 out of them. Okay. Now we are trying to find out what is the probability of getting more than 3 candies which are blue or yellow in color out of 5 pick. Here, Nanya. Yeah, Ritika. So before you try solving it, I would want to understand the approach. How would you go about it?
You said that the probability of getting blue or yellow.
Yeah. What is the probability of getting more than 3 blue and yellow candies in the pick of 5?
So then you have to find the probability of finding 1 blue or yellow candy out of the total pack and then multiply it by 3.
Okay, that is one thought. Let's see what Dave has to say.
Okay, so I was going to say, we know there's 8 blue candy and 3 yellow candy.
Mm-hmm.
So we could say that out of 11, like 11 over 16 probability for the first one. And since we're taking one out, the amount of total candies would decrease. So it'd be like 11 over 15 then, maybe, because we're like taking the candies out.
Mm-hmm. Okay. So, okay. Any other thought? Again, I am more concerned about the approach because you guys already know how to calculate it. I'm just trying to see how would you approach this problem. So would you guys want me to get started or somebody wants to quickly share? Anjika, here, anybody? No? Okay. So see, the question is, I have this many candies. I have to pick 5 out of them. We are trying to find out the probability of getting more than 3 blue plus yellow candies. That's what we are trying to find out, right? Now, let's break it down first. Now, what are the ways? We are picking up 5. We are just speaking of 5. For it to be more than 3, blue plus yellow, that means number of greens, we are talking about greater than 3. So we are essentially talking about 4 or 5, meaning where all are either blue or yellow or blue and yellow. So there is one situation where one is green, okay, this is green and everything else is blue or yellow. Or second situation is everything is blue or yellow, there is no green here. So see, by looking at the question itself, what we are seeing is that I have these many options, and the two scenarios that we are talking about is one scenario when there is only one green, so the total count of blue and yellow is 4, which is greater than 3, and the second scenario when there is no green even. So this is one probability and this is another probability, and you will find out the probability in this scenario and you will find out the probability in this scenario and you will add them together. That is what will be your, this is what I mean by the addition rule. Meaning you find out, okay, what is the probability of getting more than 3? So we are talking about essentially 4 or 5, because we are talking about 5 picks. So one is where this is 4, blue plus yellow is 4, and this one is all blue or yellow. Yeah? And then you have to find out for every position. Let's say you are saying this is green. What is the probability of getting this as green? Obviously first one, or no, let's say my first one is green. Then we are talking about 5 out of 8 plus 5 14, 8 plus 5 13 plus 3 16. My first one is green and then all 4 are blue or yellow. And what is the probability of getting a blue or yellow for the second one? If first one is green, this one is right what? So I have total 8 plus 3, 11. This is 11 out of, total was 16, now it's 15. Yep. Now this becomes 10 out of 14. This is 9 out of 13. This is 8 out of 12. This is my probability. I'll multiply them all. This gives me first probability for the first scenario. Now we are talking about no green here. So what is the probability of this being blue or yellow? So this is obviously 11 by 16. This is, okay, no. This is 11 by 16, obviously. This is 10 by 15. This is 9 by 14. This is 8 by 13. And this is 7 by 12. And I'll multiply these, and that gives, and then add them together. This is what we mean by addition rule for probability. When you have to look at multiple scenarios, find out the probability, because this is we're talking about greater than 3. That means there is a scenario which is 4 and there is a scenario which is 5. And both have to be accounted because you are giving more options. You have a higher chance. This is where it gets added. Is it making sense? Not making sense. Okay. I got 1 vote. Ritika, okay. Anush, okay. Arya,
Good, sir.
Dhanushri with me. Okay, Dave. Okay. No, I'm not going for the election campaign to get everybody's vote, but I'm just trying to confirm that is this thing making sense. So this is where you'll see that there are different scenarios that is coming into play, and you have to find out the individual probability for those scenarios and then add them together. That is what is part of your addition rule. Okay. Now let's look at what is Venn diagram. So Venn diagram is nothing but, it's more like what do you call, a more intuitive representation of the data that also helps you find out the probability. Okay. Have you guys dealt with Venn diagram before? Yep. Okay. And for some of you who have not come across it or who are having difficulty in recalling what exactly it is, you would have seen something like this. This is certainly not geometry, but this is, you would have seen that, okay, this is a superset. And then inside that you have different circles being made. And these are like the subsets, okay? Okay, so let's look at one quick example that will probably help you relate things, okay? Now let me cook up a question on the fly, okay? And then we'll see. Let's say I have 10 notebooks, okay? Which is red in color, okay? I have 10 pencils, which is, not everything has to be 10. Let's say 8 pencils which are red in color. I have 12 notebooks which are, let's say, green. Green as in the cover is green. And then 6 pens which is, let's say, red in color. Okay? And again, if I use Venn diagram to represent this, I will say, okay, what is the total number of objects I have? 10 plus 8, 18 plus 12, 30 plus 6, 36. Total number of objects I have is 36. What Venn diagram does is, you can say, okay, total number of objects, this is 36. Okay. Now, let's look at notebooks. Let's say this is my 10 notebooks. These are red ones. Okay. 10 notebooks. And then 8 pencils which are red and 6 pens which are red. Okay. Now, if I only want to see what is common between notebook and pencil in terms of color, okay, I will say this. So this is notebook, this is pencils. I'm only looking at the color thing which is common here. This is red. This is pencil, this is notebook is 10 and pencils are 8. Okay. And then 6 pens which are red. Okay. So these are pens which are red. Now look at this part of the circle, which is common in the the notebook, the pencil and the pens. Here I'm saying that only if I look at the things which are common between this one and this one. This is the common part. This is my, let's say, if red is an element of all the 3 objects, this is the common thing. Or maybe, it would have been drawn better by putting this completely inside this one. I would have said, this is my pen. Okay. So this whole color, which is inside this one, this is common. So basically, Venn diagram, if you look at it, it just, probably I'm still not giving the right example. I'm just thinking what would be the right, a simpler example. Okay, let me not deal with too many options to get you guys confused. Let me help you understand or relate to a Venn diagram in a simpler way. Okay. So let's say ten cubes, 10 red cubes and 6 yellow cubes. Okay, 6 cubes which are yellow in color and 5 triangles, which are, let's say, green. Okay. So here, the total number of objects you have is 10 plus 6, 16 plus 5, 21. So this is this complete box that you see here. This is your total sum of objects, 21. Now 10 cubes which are red. So if I'm talking about cubes, this is cubes, 10, and this is red. Okay. Here, if I'm talking about other cubes, this is yellow. This I'm not trying to draw a correlation between these two. Let me pick up a question from the book itself so that I can relate it in a way that doesn't get you guys confused. Okay, let me pick up a question on the Venn diagram from a legitimate question from the okay. Okay. Okay, I don't have to struggle so much. Okay, whatever I did for last 5 minutes, forget about it, okay? 5 or 10 minutes. Let's look at a more realistic example, okay? In this class of 10, 12 kids, let's say we have 12 kids in the class. 8 of you are champion in maths. 6 of you are champion in science. And 5 of you like US history more. Okay? Now, total kids we have is 12. What we are saying is 8 kids like maths. This is 8 kids maths. 6 kids like science. This is science. And 5 like US history. This is US history. This is 6, this is 8, and this is 5. By looking at this one, what I'm trying to say is, see, 8, 6 and 5, how much is that? 14 plus 5, 19. Total kids we have is 12. What this means is, I have kids who are champion in maths, but they also like science. There's a group of kids that is common between math and science. They like both the subjects. So the kids who are champion in science, I'm not saying that they are not champion in maths. There's a group of kids who is good in science and math both. Similarly, if you look at this particular segment here, this circle is for US history, this circle is for science, this circle is for maths. But if you look at this part completely from here to here, this is the number of kids who are liking math and science both, or who are champion in science and math both. Similarly, if you look at the red portion where this portion is common in all the 3 circles, this is the pool of kids who are good in math, science and history as well. So the Venn diagram is nothing but it just tells you, it helps you find out what is the commonality between the two disconnected things, and then you can find that out in a more intuitive way. So there could be some probability questions saying that, okay, fine, you have certain numbers given, and in the form of a Venn diagram, find out what is the number of kids who is liking math and science both. So obviously from this one there will be more information from which you will be able to find out what is this count, and then you will be able to derive that. So here we don't have all the information actually in one place, but by looking at the Venn diagram you will be able to find out what is the piece which is only maths, what is the piece which is only science, what is the piece that is only US history, and then between US history and science this is common, between US history and math this is common, and between all the three this portion is common. So from that you'll be able to derive that. So again, Venn diagram is a much simpler version. It just helps you find out a particular condition, output based on a particular condition by looking at the diagram in a more intuitive way. And every circle or every a piece of the object that you see here on the screen, that is representing a particular group, and from that you'll be able to eliminate what is common, what is separate for that particular topic or subject in that scenario. So I'm not stressing much on Venn diagram. I just wanted to give you guys just a glimpse of what is the role Venn diagram plays in finding out the outcome or the probability. So if you have, let's say, 12 kids, from this they say, okay, find out what is the probability of finding kids who are good at math and science both. So you'll find out this particular area and the corresponding value for this, and then divide that by 12. That will be a probability of finding kids which is meeting that particular condition. Okay, so it is just nothing but the simpler version of how you look at probability, or how do you relate different things and then derive interpretation from that for calculating your probability. So I know last 10 minutes were quite boring. I was myself struggling to figure out how do I give you guys the right example so that I can explain the Venn diagram, and I could not find the most appropriate one. After a bit of struggle I could get to this one. But any questions so far? I know there's not much that is remaining to talk at a concept level, but if you guys have any doubts, anything that you think is not clear, let me know, because after today I'm planning to switch to other topics. So let's use next 5-6 minutes to understand if the concept that we have learned so far, are we able to relate, or there are some still open areas which needs any further deliberation. No? Okay. Dave, Ritika, Chris, Dhanushree.
I understand.
Understood. Anjika, okay?
I understand.
Okay. So the summary of this is this. Now, next 5 minutes, let me give you guys some spiritual speech. Don't get scared. I'm very poor at giving spiritual speech. I only talk maths. Now, when you talk about permutation combination, any question for that matter, when you are dealing with this, you have to only keep two things in mind. One is this equals this divided by n minus k factorial, and second one is n combination k, which equals factorial n divided by factorial n minus k factorial k. Now you have to be very clear about how do you apply, when do you apply this and when do you apply this. We are looking at finding out different options to where the order between the selection matters, you'll go for permutation. When the order doesn't matter, you just look at finding out number of groups, that is when you go for combination. Next thing is, any question that you pick up, try drawing a decision tree. That will give you a much clearer view of how you want to look at. Third thing is probability. If you have to find out the probability of a certain event, you have to look at what is the total number of options. What is the total number of likely event by total number of events. Likely event by total number of events. That is what will give you the probability. And this remains your basic thumb rule. So you'll find out for the given question what is the number of likely events you're talking about, divide by total number of events. That will be your way to calculate probability. Now, whether this likely event you're finding by permutation or by combination, that will depend on the the question that you're dealing with. Yeah. And then next thing is, if you are talking about, next thing was that the disconnected and unconnected events, or connected and connected and independent probability. So when you talk about independent probability, you'll find out the probability of all the independent events and you will multiply them. When you're talking about connected events or related dependent probability, you'll find out the probability of all the related steps, and then you'll multiply them. But you have to keep in mind that one event is dependent on the previous one, so that you have to take into account. And then we talked about the addition rule, where you're talking about multiple scenarios to get the probability, and you have to find out the overall one. It's nothing but simple addition. So you find out the probability for the given scenarios, like we talked about greater than three scenarios, right? So it means 4 and 5 is also into a picture. Find out probability for the first scenario, find out probability for the second, third, all that applies, and then add them together. So this is just a summary of all that we have learned. I think I saw somebody raising hand. Was it Aryan?
That was on accident, sir.
Okay. All right. So that pretty much brings us to the end of the class. And we had a couple of minutes. Any questions? He has been pretty quiet today. Any questions, Beta?
No, sir, I understand.
So again, the videos of the class will be uploaded and you can always use that for your reference. There will be things that I will get you confused about, but then the only way is these videos will actually help you do a revision of what we have learned in the class, where I have gone wrong. And there could be places where I might have gone wrong. You can always say that, sir, this part I think you got me confused, or this is not right. You don't have to blindly follow what I say. I'm just kind of guiding you guys with the concept, but if I say something wrong, please feel free to let me know so that I can do the correction and make sure that everybody gets it right. Alright? Anush, so far so good?
Yes, sir.
Okay. Yeah, I mean, you have heard me the least in this group, so that's why I keep checking with you, okay? Alright, so that brings us to the end of the class. Enjoy the rest of your weekend. And I would suggest you guys to do the unit test on Khan Academy for the topics that we have learned, and see whatever we have learned, is that good enough for you to be able to solve those problems? If not, come back to me. Yep.